Alright everyone, today we're going to go over the Chapter 8 Polynomials Test review. You are going to be given these two formulas for the sum of cubes and the difference of cubes, and then you will be able to use your notes in some cases for those regular classes. So let's get started. Classify negative 9x to the fifth minus 3x cubed plus 9x squared plus 6. And we're going to want to classify that by degree and the number of terms. For degree, remember that's just another way to say exponent. And we want the highest exponent that we have, so this is going to be a fifth degree. And what you also want to remember is that fifth degree had a special name. The special name for fifth degree is going to be quintic. And then by number of terms, you just want to count out how many things are getting added and subtracted in here. So 1, 2, 3, 4. So it's going to be a quintic 4-term polynomial. Remember, 4 and on, they just go 4 or 5-term polynomial, but everything before that would be monomial, binomial, trinomial, and then 4-term polynomial. Moving on to question 2. We want to write 2x squared times 4x squared minus 3x cubed in standard form. So to write this in standard form, you just want to distribute here, multiply that out. So we're going to get 8x to the fourth minus 6x to the fifth. And then this isn't in standard form. You multiplied it out, but you want to write it in standard form. So you're going to want to write it in decreasing degree. So we're just going to have to move those terms around. Negative 6x to the fifth plus 8x to the fourth. And then that's done. That's going to be it in standard form. What is the end behavior of the polynomial f of x equals to all this? I'm just not going to read all of these out the entire time. For end behavior, you're going to want to find two things. The first thing that you want to look at is, well, you want to make sure this is written in standard form, which this is. So you're going to want to get the highest degree and the leading coefficient. So the highest degree, we know that that's odd. And then the leading coefficient, that's going to be a positive value. And so you're going to want to recall that end behavior is going to be when the degree is odd but a positive leading coefficient. That is going to be going up on the right and then down on the left. So how do we describe that? Well, we're going to say as x approaches negative infinity, y approaches negative infinity. So this means it's going down on the left side. And then to describe the right, so it's going to be x approaches positive infinity, the right side. Then y is going to approach positive infinity. This is going up. And then this is how your answer is going to look. Number 4, we want to simplify this expression. In order to simplify, you're going to want to distribute that negative over here. There's nothing to distribute into the first binomial. So we're just going to bring that down, x squared minus 144 minus x squared plus 24x minus 144. And what you might notice is that we have these terms that are going to cancel out. X squared minus x squared, those are opposite, so they're going to cancel out. And then we just need to write the remaining stuff in standard form by combining like terms. So 24x first, 24x minus 288. Negative 144 minus 144 is negative 288. And that's going to be simplifying the expression. No like terms and no parentheses left over. Here we are in number 5. Write the polynomial in factored form. Remember, I told you the first thing you have to look for when factoring in any polynomial is a greatest common factor. So I see that all of these can be divided by 2x. So we're going to divide them all by 2x and bring that 2x to the outside of the parentheses, and we have now x squared minus 3x, and then 36 divided by 2 is going to be negative 18. And this is a quadratic trinomial in here that can be factored, and we want to see what are those going to be that come out to be negative 3. So we'll look at that. And is going to be negative 6 and positive 3. So those are going to be the two binomials that I can write out. So we still have that 2x still chilling. And then it's going to say now x minus 6 and x plus 3. Those are going to be the factors of x squared minus 3x minus 18. If this could not be factored up in this area, then this would be your final answer. But since this trinomial could be factored, which you always want to check, then we will factor it further. But if it couldn't, you just leave it. All right, here we are in question 6. Write a cubic polynomial in standard form with these zeros. And those zeros are going to be x equal to negative 3, x equal to 1, and x equal to negative 2. And you want to remember how zeros are affected by factors. Really, they're just, we get factors, or we get zeros from factors. So what can the factor be that gets me x equal to negative 3? Well, that factor could be x plus 3. Because if I set that equal to 0, I'll get x equal to negative 3. And that's exactly what we're going to do for each of these. We're going to get x minus 1 and x equal to, sorry, not equal to, x plus 2. And we're going to sit here and multiply these out. So let's see, I'll get x squared. I'm going to still need a parentheses. And then minus x plus 3x, that'll get me plus 2x. And then 3 times negative 1, that'll be negative 3. We still have this x plus 2 coming down, and we have to now multiply everything by x plus 2. X squared times x is x cubed. X squared times 2 is 2x squared. 2x times 2x is 2x squared. 2x times 2 is going to get us 4x. Negative 3 times x is negative 3x. And then negative 3 times 2 is negative 6. So then combining our like terms, we're going to have x cubed plus we have these like terms next, so plus 4x squared. And then these like terms here, 4x minus 3x, that's going to be plus x. And then the minus 6 still comes down. And this is going to be the simplest polynomial that we can find that goes to those 3 zeros that were given. Number 7, we want to use our calculator here to find the relative max and relative min of this function. So let me pull up my calculator. All right, there. Now you can all see that. And we're going to add this graph. I'm just going to type in the function that we were given. And the easiest way to do this on the TI Inspire is to go Menu, Trace, Graph Trace. We see that we have a maximum here and a minimum here. So to find that relative maximum, you just click until this little flag that came out. Let me get that back. Maximum. And so this coordinate is going to be our maximum. Let's see, negative 0.734, comma 2.63. All right, and that was a max. That was a relative max because it's not the greatest. And then a relative min. Just click to the right now. Click, click, click. And our minimum, 0.568. Comma, negative 1.78. So that's going to be our relative max and our relative min. If we had more, then we would list others as well. But those are the only 3 that we had in this case. Number 8, we want to see what are the real or imaginary solutions of this polynomial equation. What you want to notice between 27 and 125 is that those are both cubes. So we're going to want to use that, and we notice that we have a sum here. We're going to want to use that formula for sum of cubes. So let's write that down first. So if we have a cubed plus b cubed, well, that's going to be a plus b times a squared minus a times b plus b squared. And again, you will be given this formula on the test. Well, you might know, like, these aren't cubes unless you write them as cubes. So 27, well, that's going to be 3 cubed, and it's 3x cubed. If you want to, you could write this out 3 times, 3x times 3x times 3x, and notice that it comes out to be 27x cubed. And 125 is going to be plus 5 cubed. All right, so those are going to be my a and b values that I'm going to have up here. So that's a and that's b. So a is going to say 3x plus 5. And then we're going to have a squared, so that's going to say 9x squared. Because what's happening here is you're going to want 3x in parentheses, and then that's what gets squared. So 3 squared is 9, and x squared is x squared, minus a times b, so 3x times 5 is 15x. And then b squared, so 5 times 5, that'll get us 25. Just following that formula. Well, this is equal to 0, so now we can use our zero product property. 3x plus 5 equals 0. We solve for this, subtract 5 divided by 3, we're going to get x equal to negative 5/3. And then over here, if you remember, I said that these can never be factored. So don't sit here trying to factor this. It can't be factored. What you're going to want to always jump into is the quadratic formula. So x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. So here we have a, b, and c. So let's see how this goes. X equals negative b, so positive 15 plus or minus the square root of b squared, negative 15 squared, minus 4 times 9 times 25. All over 2a, so it's going to be 9 times 2 is going to be 18. And let's see what we can do with this. So we're going to have 15 plus or minus, and here I'm just going to type that into the calculator. That's negative 675. Is that a perfect square root? No, it's not. But I know that can be divided by 25. And that can be divided by 9. And 25 times 9 is 225, which is a perfect square. Alright, so we're going to get the square root of negative 675 over 18. And then all that stuff I was just checking a second ago. Well, negative 675, the square root of negative 675, this can be simplified going square root of negative 1, square root of positive 675, and then going further down, square root of 675, that's going to be divisible by 225. So square root of 225 times the square root of 3. Well, this is going to get us I, and that's going to get us 15. So we have x is equal to 15 plus or minus 15i square root of 3 all over 18. And 15 and 18, those can be simplified as well. So 15 over 18, that's going to get us, let's see, they're both divisible by 3, so 5/6. So 5 plus 5i times the square root of 3 all over 6. And that's going to be the final answer for this part. Don't forget, we had this row 0 over here, negative 5/3. And then these two imaginary, two complex zeros, 5 plus 5i squared root of 3 over 6, and 5 minus 5i squared root of 3 over 6. So 1, 2, 3 answers, which is how many we need to have because it's a cubic function. Alright, here we have to use grouping to fully factor this polynomial. So for grouping, you're just going to put what you have here into groups, and then we're going to factor out the greatest common factor from each group. So in this first one, in this first group, we're going to take out this x squared, and we're going to have x minus 2 left. And then over here, we're going to factor out a negative 9, and it looks like we'll have x minus 2 left in there as well when you divide both of those by negative 9. Well, this x minus 2 is the same, so we're going to factor that out from them. So x minus 2, and then we have x squared minus 9 left over. Well, this x squared minus 9 is a difference of squares, so that can be factored again. So we have x minus 2, and then x plus 3, and then x minus 3. So this is going to be the fully factored form of this polynomial. Here we want to use division to divide this polynomial by 4x squared plus 2. And remember, if this is quadratic, we have to use long division. So let's write this out. 4x squared plus 2, and then long division. Don't forget your 0 placeholders. 4x to the 4th plus 0x cubed plus 14x squared plus 0x plus 12. You really need those placeholders in there. So 4x squared times what gets me 4x to the 4th? That's going to be x squared, and then you want to distribute this in. So x squared times 4x squared, that gets me 4x to the 4th. X squared times 2 gets me 2x squared. Put your parentheses and subtract just like regular long division. Those cancel out. And 14 minus 2, that's going to get us 12x squared plus 0x plus 12. Back to that original question, 4x squared times what gets me 12x squared? Well, 4x squared times 3, so let's see, positive 3. And distribute that, 3 times 4x squared is 12x squared. And then 3 times 2 is positive 6. Okay, parentheses and subtract, 12 minus 12, that gets me nothing. 0 minus 0, that's nothing again. And then 12 minus 6 is 6. Don't forget, this is going to be your remainder, and write this out as x squared plus 3 plus 6 on what we were dividing by, 4x squared plus 2. This is going to be your final answer right there. Alright, so here's going to be kind of a definition question. What similarities and differences does synthetic division have with long division? Long division is what we just did on the last problem. So go back if you want to go see long division. Well, what similarities do they have? They're for polynomials. Dividing polynomials quickly. And they both have this multiplying and adding happening. So there's multiplying and then it goes into adding or subtracting. But something that's different between them is that synthetic division, that's where we are adding, and then long division we are subtracting. Another difference is with synthetic division, this is only for linear binomials. You can only divide by linear binomials, whereas with long division, any polynomial. So there's a lot we could write here. Just review how each of those work so that you can answer a question similar to this. Next, question 12, we want to see, is this a factor of that polynomial? Why or why not? So you're going to want to just go synthetic division. So synthetic division, set this equal to 0 and solve, so we're going to get x equal to 4. And that's what we're going to put into the corner. And 2 minus 13 plus 26, sorry, that's we don't need that plus sign there. Minus 24. Just the coefficients of the polynomial. This is synthetic division, so 2, bring the 2 down, 4 times 2 is 8, negative 13 plus 8 is negative 5, 4 times negative 5 is negative 20, 26 minus 20 is 6, 4 times 6 is 24, and those cancel out and we get 0. So is this a factor? Yes, it is a factor because the remainder is 0. And you're going to want to go back and look at the factor theorem, which states that if the remainder is 0 and what we are dividing by, x minus 4, is a factor. So factor theorem. Here we want to classify the polynomial by degree and number of terms. So you're going to want to multiply everything out, these two binomials, and we're going to go 5 times 4, we're going to get 20. And then 5 times 3y, we're going to get 15y. And then negative 2y times 4, that's going to get us negative 8y. And negative 2y times 3y, that's going to get us negative 6y squared. So let's write this in standard form real quick. So negative 6y squared. 15y minus 8y is going to get me plus 7y. And then plus 20. Well, by degree and number of terms, this is a second degree and it has 1, 2, 3 terms. So second degree is quadratic. And a 3-term polynomial, those are trinomials. Make sure you have all of those names written down somewhere for your notes. Next, we want to identify the mistake in this work. Now, if you look through it, this is not the addition and subtraction that we're used to. So as I go through it, I see that they're combining the like terms first and then performing the operations with them. Well, if you were looking through it all, the mistake that's happening is these two minus signs. Because what's happening is those should be plus signs because we want to add. And then this negative 4x squared, the negative would be inside of the parentheses. And then the negative x here, sorry, it would be this negative x. This negative x would be right there inside of the parentheses. And since they have the negative sign outside, it is actually affecting the results. So this is how it should look. And then if you fix it, you go from there, you're going to get something way different than this. And then this is kind of a larger question. We want to write the end behavior, the turning points, and increasing and decreasing behavior of this polynomial function. And we're going to get this all from the graph. Alright, here's my graph, and those turning points, you're going to want them to be those maximums and minimums. Actually, let's start with the end behavior because it's pointing down on the left and pointing down on the right. So going back to that question that we had earlier to begin, the end behavior pointing down on both sides, well, we're going to say, let me label this end behavior. As x approaches negative infinity, so the left side, my y values are going down, so my y values are going to negative infinity. And then as x approaches positive infinity, my y values were going down again, so y approaches negative infinity, sorry. Now we want to get those turning points. Those are going to be our maximums and minimums, so we just need to write those out. And let's see, menu, trace, grab trace, and let's start. I see a maximum over here, negative 1.38 and 7.68. Negative 1.38, 7.68. The next one is going to be 0.655, comma, negative 6.72. And then the last one that we have is 2.22, whoops, and 0.475. And then we want to write, so those are 3 turning points, how many times that it turns. And we want to write where the function was increasing and where it was decreasing. So increasing behavior is where the graph is going up. So we go up from all the way on the left, and then it keeps rising up to that maximum up there, which was that first turning point. So we're going from negative infinity to this first turning point, that negative 1.38. We only want the x values. Well, there are other parts where the function is increasing. So from here to there in that middle part. And again, we only want the x values of the two turning points. So 0.655 and 2.22 on those intervals only. And then the decreasing behavior, where's the function going down? Well, it's going down from the maximum to this minimum. So negative 1.38, the x value of the maximum is here, and then 0.655. And then it keeps going down on the right side from this maximum, and it just never stops going down, never stops decreasing. So that's going to be to infinity. So union 2.22 comma positive infinity. Those are the decreasing points there. Alright, just ignore all those little red squigglies. It was giving me some problems on the spell check. Doesn't know that those are numbers. But what's happening is you get a kind of like a polynomial search, and you're going to have to find some polynomials on the test. And what you're going to want to do is simplify these first. So if it says 4x squared minus 2x squared, that's going to be 2x squared. And then 7x plus 10x, that's going to be plus 17x. And then I made a mistake. So 4x squared minus 2x squared, that's going to be 2x squared. And then 7x minus 10x, that's going to be negative 3x. And then 9 minus 4, that's going to be positive 5. So we have those three. We want basically to see this in a row on your polynomial search. So just look for that down below. I'm not going to do all these. I'll just do a couple more. So over here we have x to the fifth. I don't have any other x to the fifth, so it's just going to be x to the fifth. And then I have this plus x to the fourth. No others to combine that with, so plus x to the fourth. Well, negative x cubed minus 2x cubed is going to be negative 3x cubed. Negative x squared minus 2x squared, that's going to be minus 3x squared. Only this positive 4x, so plus 4x. And then 3 minus 3, those cancel out. And that's the polynomial I'll be searching for. How about a couple more? So starting here with this 8x to the fifth. No other monomials to the fifth degree, so just start with 8x to the fifth. And then 8x to the fifth, we're done there. So negative 2x to the fourth plus 8x to the fourth. It's going to be plus 6x to the fourth. Let's see, what's next? I have negative x minus 3x, so that's going to be minus 4x. And then 3 plus 1 is going to give us 4. And one more, 7x to the fourth minus x to the fifth. Sorry, highest degree, x to the fifth. So that's a minus sign, so kind of distribute that across. So that's going to start with negative x to the fifth. And then 7x fourth minus negative 2x to the fourth. So that's going to be plus 9x to the fourth. Then minus negative 6x cubed, so it's going to be plus 6x cubed. And then minus 2x squared. And then we have those x's to combine, so 5x minus 4x is just plus x, and then plus 4. And you'd be looking for that polynomial somewhere in the search below. Alright, so that's all that's going to be covered for this last question. You can do the rest and check them later. But good luck on your test, on your Polynomials test. If you have any questions on any of this work, just let me know. I'm Mr. Hernandez, and I'm always here to help.